Hi friends, in this video let us see some definitions of illumination. As illumination or the light is some different energy, so we need to know some basic definitions so that we can go further. So how to identify the illumination and how to calculate the luminous intensity and all these things. So let us first briefly discuss all the definitions we are having. The first definition is plane angle theta. So this is the statement for the plane angle, the definition. So the definition is when two lines are lying in the same plane meet at a point, the angle formed is called a plane angle. The angle is measured in radians. So this is the thing. Actually there are two lines. One line is like this and the other line is having some angle, and that angle is called plane angle theta, and these two lines subtend some arc of length L. So we can simply define the plane angle theta is equal to arc divided by radius, where L is the arc and R is the radius. So theta is the plane angle. So this is the definition for plane angle. Theta is equal to L by R. And the next definition is solid angle omega. So solid angle means the angle subtended by an area of a point is called solid angle. It is measured in steradians. So this is the thing. Actually this is subtended by some angle. In the previous case the angle subtended by the R, but here it takes some angle it takes some area. So that area is called A, and theta, this is omega not theta, and omega is the solid angle and R is the radius of the circle. So solid angle omega is equal to area divided by radius square, where area A is this shaded area. Okay, that I have marked it as straight line. So that shaded area divided by radius square. Next, the next definition is illuminous flux. Luminous flux, so it is the rate of energy radiated in the form of light waves, and its unit is lumen. So let us see. Yeah, this is the thing. Luminous flux phi is equal to radiant energy Q divided by time T. So this is the main formula. Just remember this. And the next one is lumen, LM. Lumen is the unit for luminous flux. Let us see. One lumen is defined as the luminous flux emitted by a source of 1 candle power in a unit solid angle. So this is the definition of lumen. So lumen is defined as the luminous flux emitted by a source of 1 candle power in a unit solid angle. So the formula is like this. Lumen Lm is equal to candle power Cp into solid angle omega. Now let us see what is meant by candle power. Yeah, candle power. So the candle power means it's defined as the number of lumens emitted by a source per unit solid angle in a given direction. So it represents the light emitted capacity of a source. Next. Yeah, the next thing is illuminance or illuminous or degree of illumination. So it is represented as capital E. This is also very important definition. It is defined as the luminous flux received by the surface per unit area. In its unit is lux or meter candle or foot candle. This is the equation. Illumination or degree of illumination or illuminance or illuminous. Capital E is equal to luminous flux phi divided by area A. Yeah, this is the meter candle or lux. It is the unit of illumination received inside a sphere of radius 1 meter with a source of 1 candle power at its center. The next one is foot candle. Foot candle is same definition. It's the illumination of the inside of a sphere of radius 1 feet. If it is measured in feet, then it's called as foot candle. So 1 foot candle is equal to 10.76 lux or meter candle. The next definition is luminous intensity, capital I. It is defined as the illuminous flux emitted by a light source per unit solid angle. So capital I is equal to 5 by omega. Its unit is candela. Yeah. Luminous intensity, capital I is equal to luminous flux 5 by solid angle omega. Luminous or radiant efficiency. So the ratio between the energy radiated in the form of light to the energy radiated by the in all forms of energy. So total energy radiated in all other forms, maybe that is heat and other things, is known as radiant energy efficiency or radiant efficiency or luminous efficiency. Yeah, radiant efficiency is equal to energy radiated in the form of light to total energy radiated by the body. The next definition is brightness. So it's defined as the luminous intensity. So it's a capital I per unit projected area of the surface in the given direction. So this is capital L. Brightness, capital L, is equal to luminous intensity, capital I, divided by apparent area, capital A. Next, what is meant by luminance? Luminance. When brightness is considered in terms of measurable quantity, the term luminance is employed. It's a brightness, okay, but it is in terms of measurable quantity. Bigger unit of luminance is stilb, STILB, which is defined as the candelas per square centimeters. Candle per centimeter square. So the next definition is unit diffuse source. That means a uniform diffuse source. A uniform diffuse source is one in which the intensity per unit projected area is the same from all directions of view. The next one is illumination level. That means how much level of illumination is there at that point. The term means the amount of illumination required to do a job satisfactorily. So how can we get it? So more light is needed in hospital operations theater compared to the normal office work. So that is the satisfactory level. That means for hospital, for getting satisfactory level, you need to produce more illumination, and the satisfactory level of office is different. Satisfactory level of some other activity is different. So that is the luminous level. Coming to reflection of light, let us see some definitions in reflection of light. What is meant by reflection of light? When light falls on a polished surface or smooth surface, it may partly reflected. So the phenomenon is known as reflection of light. So the ray of light falling on the surface is known as incident ray, and the ray of light going away after striking the surface is called in the reflected ray. So the next one is specular reflection. That means when the surface is smooth and perfectly reflecting, all the light is reflected. That is, the angle of incidence is exactly equal to the angle of reflection. In this case, a sharp image of the source is also appeared in the surface. So this is known as specular reflection. Specular means it can be visible. That means which one is visible? The source of light can be visible. So the next one is diffuse reflection. That means when the light is incident on a rough surface, then it is scattered or diffused in all directions, and hence no image of the source is formed. Such a reflection is known as diffused reflection. So whenever light incident on the surface, it will be scattered and diffused. Next, what is meant by glare? It may be defined as the brightness within the field of vision of such a character as they cause annoyance, discomfort, or interference with vision or eye fatigue. Then that is called glare. Next, what is meant by lamp efficiency? Lamp efficiency is defined as the ratio of the luminous flux to the power input. So it is measured in lumens per watt. Next, specific consumption. What is meant by specific consumption? So it's defined as the ratio of power input to the average candle power. So it's expressed in watts per candela. So let us see some of the candle powers. There is mean horizontal candle power. So the definition is it's the mean candle powers in all directions in the horizontal plane containing the source of light. Here we have considered the mean of candle powers in all directions on horizontal plane. So it's limited only to the horizontal planes. Next, mean spherical candle power. That means it is the mean of candle powers in all directions and in all planes from the source of light. So it covers all planes. So it is represented as total flux in lumens by 4 pi. Next, mean hemispherical candle power. What is meant by this? This is the mean of candle powers in all directions above and below the horizontal plane passing through the source of light. Just above and below. Hemispherical candle power. Either above or below. Okay. Spherical means it takes all mean of the candle powers in all directions in all planes. But coming to hemispherical candle power, it will take either below the source of light or above the source of light. So this is half of the upper one in general. Next, there are some factors and ratios. Those we need to study. Let us say them. Relative luminosity factor. That means the sensitivity of the eye to yellowish green radiation is taken as unity. That was already discussed in the previous video, and which is equal to 100% of the sensitivity, and the sensitivity to other wavelengths is expressed as a fraction of percentage of it in general, and the relative sensitivity at wavelength lambda is written as k lambda, and this is known as relative sensitivity. Okay, this is known as relative sensitivity. Next, what is meant by reduction factor? This is the ratio of MSCP to MHSCP, that is MSCP by MHSCP. So that is called reduction factor. Okay, what is MSCP? Mean spherical candle power to mean hemispherical candle power. The next factor is reflection factor. So this is the ratio of reflected light to the total incident light on the surface. Very simple. Reflection factor is equal to amount of reflected light to total incident light. Next, utilization factor. What is meant by utilization factor? The ratio of total lumens reaching the working plane to total lumens giving out by the lamp. So there are so much of energy given from the lamp, but we are unable to get the complete energy. Some energy is wasted in between. So that ratio is called utilization factor. And the next one is waste light factor. So it's also called as coefficient of utilization. Waste light factor is called coefficient of utilization. It is the ratio of light incident on the working surface to the total light emitted by the source. Okay, that is the difference. Next, the maintenance factor is, it is the ratio of illumination under normal working conditions to the illumination when the things are perfectly clean. So that is called maintenance factor. Depreciation factor. So what is meant by depreciation factor? This is the reverse of maintenance factor and is defined as the ratio of initial meter candles to the ultimate maintained meter candles on the working plane. Its value is more than unity naturally. Next, absorption factor. So what is meant by absorption? Absorption factor. In places where atmosphere is full of smoke and fumes, that type of environment is there, such as in foundries, and there is a possibility of absorption of light. In those things, the light will be absorbed. So the ratio of total lumens available after absorption to the total lumen emitted by the source of light is called absorption factor. The next one is beam factor. The ratio of lumens in the beam of a projector to the lumens given out by lamp is called the beam factor. This factor takes into account the absorption factor of light by reflector and front glass of the projector lamps. Its value is varying from 0.3 to 0.6. Next, space height ratio. Okay, this is also very important thing. So it's defined as the ratio of horizontal distance from adjacent lamps and height to the mountings. So the value of ratio in practice is 1 to 1.5. So it's a ratio of horizontal distance between adjacent lamps and the height of the mountings. So these are the various definitions and various factors involved in illumination engineering. So please try to read all of them and try to have a very good idea of them, so that from this onwards we need to keep on memorizing all these things, and we need to keep on using all these things in the theory and also in practice. Okay. Next, thank you for 1370 plus subscriptions. If you like this video, please like it. If you want to share this video, please share with your friends, family, colleagues and students. If you haven't subscribed to my YouTube channel, please try to do that, and please press the bell button so that you will get the notifications whenever I upload any video. Thank you so much.